So in this part we will, after occupying our position and determining our exact position and making all the data, collecting all the data what we need to for our calculation, in this part we will just make our calculation after reviewing our data, because I have reviewed my data and I just found that I just mistyped. The headwind is not minus connection, this plus correction, because I have a headwind, so I need to add some range to that. Well, anyway, let's go to the calculation part and the little explanation of what everything is and how to calculate with everything. Because you have the RC, it is the range correction. The range correction comes that your actual range always falls in between the two base ranges, like the base range of 3,500 and the next base range, which would be 3,600. So it is 60 meters more, and you need to compensate for that. And how do you compensate for that? It is that you have the elevation change for 50 meters, which is 50 mils. What you need to do is you divide the elevation change needed for 50 meters by 50, and you get that for each meters how many elevation change you need. And what you do is just to multiply it by the actual your difference between your actual range and the next base range. So what you have to add to it. That's how easy it is. All you need to do is just to substitute the abbreviation. So target range was 3,560. Our base range was here 3,500, and the elevation change needed for 50 meters was 15 mils, and divide by 50, and all you have to do is just to do the math. 3,560 minus 3,500, that is 60, and you multiply it by 15 divided by 50, and that comes to 18. That comes to 18 mils. So let's do it again. 15 divided by 50, that's all 60, that's 18 mils. So our range correction is 18 mils, but if what sign it is plus or minus, we need to understand that we are shooting high angle here, and we always want to add to the base range. To add well, until the next base range, 60 meters, you want to add to that range. And in high angle, if you want to add to your range, what you do is you depress your gun. So it is going to be a negative compensation. And here, the next one is AC elevation compensation. What you need to compensate for the elevation. How much? Well, you need the AD, the elevation compensation number, which was what? Elevation compensation was 15 mils. So each 100 meters of elevation difference, you need 15 mils of the barrel elevation difference to compensate for. So how you calculate that? What actually need, because you have actually 6 meters, well, you need to the elevation compensation. You divide by 100. In that way, you just get that. For 1 meter of elevation difference, how much barrel elevation you need to compensate for, and multiply it by your actual elevation difference. You see, that's how easy it is. So elevation compensation number was 15. Our actual elevation was plus 6 meter, and need to divide it by 100. That's not going to be something big, but it is 0.9 mils. You round up at the end, that is 0.9 mils. But it is, again, you need to do some mental work here, because it is, though it's 0.9 mils, it is a little bit, our target is higher than us. And if the target is higher than that, as it is as if we want to shoot further to hit something which is higher than us. It means that we need to aim further a little bit. And that gives us how much further we need to aim. But the thing is that we are shooting high angle, and we want to aim further. That means we need to depress our gun. There is also going to be a negative compensation. And now you have the headwind compensation, and it's pretty easy. You just need the headwind compensation number gives you for each meter per second of headwind how many meters you need to add or decrease your aiming point, your range. It is 7 meters, and the headwind correction is 7 meters, and what you need is your actual headwind, and our actual headwind was plus 2.3. Plus 2.3. Let's do the math. 2.3 multiplied by 7, that gives us 16.1 meter, and you add 16 point, and it is positive. 16.1 meters. We need to add to that, to our aiming point, to compensate for our headwind. How about the side wind? The side wind is mil. because from the side we will compensate with wind. The side wind, we need the side wind compensation number, which is 1 meter. That means for each meter per second of side wind, we need to compensate with 1 mil back and forth at that distance. But our side wind was minus 1.4. Minus 1.4. So that means it's pretty easy. Minus 1.1, it's a minus 1.4. So we need to decrease our azimuth for minus 1.4 mil for that range with this side wind. Temperature correction. It is again, all range tables are calibrated for 15 degrees, and whatever you have a difference from 15 degrees, you can compensate for that. But how? It is easy to understand knowing some ballistics that when the air is warmer, that means it is thinner, so our bullet wants to fly further. If the air is colder than 15 degrees, the range table is calibrated for, the air is denser, so our bullet wants to fall shorter. So how do we calibrate it? When it is warmer, we just decrease a little bit our aiming point. When it is warmer, when it is colder, we need to increase a little bit. But how much? Because the temperature compensation number, it gives you the 27 meters for each 10 degrees of temperature difference from the 15 degrees. We need to add or subtract 27 meters of range. You see, that's how easy it is, the temperature compensation. But in order to do that, well, you need to understand that. So the temperature compensation number you divide by 10 degrees, and that way you give that for 1 degree of temperature change, how many meters you need to change your aiming point. And here you actually get the difference between your actual temperature and the normal temperature with the proper sign if it is plus and minus, because if you subtract from 15, you get the right number if it is plus or minus. So 15 minus 22.3, that's our actual temperature, and the temperature composition is 27 meters. I just need again to do the math. 15 minus 22.3, that equals minus 7.3, and you need to multiply by 27 and divide it by 10, and you get that 19.71 meters. But since our temperature now is 22 degrees, so that means it's higher, that means we need to decrease our aiming point with 19.71 meters. The pressure compensation, it is pretty much the same. The normal pressure what the range tables are calibrated for is 10 to 13.25 hectopascal, and for the pressure compensation number gives you the number which you need to compensate with your range. 6 meters you need to compensate for each 10 hectopascals difference from the normal temperature, like normal pressure 10 to 13.25. So in order to, but it is different, because if the pressure is higher, that means the air is denser, it wants to fall short. If the pressure is lower than your normal pressure, that means the air is thinner, so we need to compensate for that by aiming shorter. So it is different. You are subtracting the normal pressure from the actual pressure, and then multiplying it with each 10 hectopascal what you need for the pressure compensation number for 1 hectopascal. So our actual pressure was 1009. You divide 10 to 13.25. You subtract, and you have the pressure compensation number, which is what, 6 meters, and you just do the math. 1009 minus 1013.25 gives minus 4.5 multiplied by 6 and divided by 10. That gives us 2.55 meters, and that is meters, 2.55 meters. But 2.55, but our pressure is 1009, so that means our pressure is lower than the normal pressure, and it wants to fly further than. If the pressure is lower, it wants to fly further, so we have to decrease our aiming point with minus 2.55 meters. That's it. We just did the meteorological calculations, and now we need to convert all these meteorological calculations into actual elevation difference. How do we do that? Well, we need to add up all this headwind correction, the temperature correction, and the pressure correction, which are range correction. The side wind is not, it is azimuth correction. The headwind correction, the temperature correction, and the pressure correction. The headwind correction was plus 16.1 meters. The temperature correction was minus 19.71 71 meters, and the pressure correction was minus 2.55 meters. And you need the RC1, the range change for 1 mil. That means basically how do you convert that distance to your actual elevation difference? It is that you divide by the number which are corresponding the distance which corresponds to 1 mil of elevation difference, which is 4 meters. It's not really, but don't bother that. Don't worry about that. It is just how these things work. It is some experimental stuff, so don't question anything. Just do what it says. So 16.1 meter minus 19.71 minus 2.55. That means minus 16.6. 16 meters divided by 4. That means minus 1.54 meters. The thing is, the problem is that the calculation itself does not know if you are shooting high angle or low angle. So, but the thing is that you need to decrease. You see that the adding up all the meteorological compensation that gives a negative number. So we to aim shorter. To aim shorter at high angle, we need to elevate our gun. So that is going to be a plus compensation, or plus 1.54 mils. That's it. You did the first part of the calculation, and you need the corrected azimuth. How do you correct the azimuth? Well, you need the target azimuth, which was 3904 mils, and obviously you need to correct for the side wind. We discussed that for the side wind we need to subtract 1.4 mils, and you need the drift, which is minus 42. So you also get to minus 42. And you do the math. 3904 minus 1.4 and minus 42. That gives us 3861. Because here you need to round up. 3861 mil. But this is, be aware that this is map azimuth. It is not magnetic azimuth. The intercept that map azimuth into my magnetic device, which is the aiming circle. You know, from map azimuth to magnetic, you need to subtract 98, and the other ways is to add. So it's 3861 and subtract 98. That gives me 3763. 3763, because that is the magnetic azimuth I need to intercept with my aiming circle. And now we have the corrected elevation. What we basically is adding up all the stuff you just calculated here. You need the base elevation, what was 1032 mils, and you need the range correction, which was what, minus 18 mils. You need the elevation correction, but for the elevation difference was minus 0.9, and all the meteorological correction we just added up, which was 1.54, and you see why I'm not really rounding up things just at the end. So 1032 minus 18 minus 0.9 plus 1.54, that gives me 1014.64, and now you need to add up to it's just 1014. That's our correct elevation. So this is the two thing I need, and charge 2 obviously. I'm shooting here charge 2. Charge 2. So that's what you need. You need your correct azimuth and your correct elevation, and then you can go to lay your gun.